Coming up on episode 32 of Omnivore, Innovation Down Under, the latest research in cultured meat, and the business case for food traceability. This is Omnivore, from the editors of Food Technology Magazine and the Institute of Food Technologists.
This episode of Omnivore is brought to you by IFT's Global Food Traceability Center. Get ahead of FDA's food traceability rule compliance deadline with the Enterprise Traceability Education Suite, your unbiased source for comprehensive traceability training. Learn more at ift.org/traceability.
Welcome to Omnivore from IFT and Food Technology, where we explore the intersection of business, science, and technology in the global food system. I'm Bill McDowell. Whether it's new products, processing technologies, or farming methods, there's no shortage of food innovation happening around the globe. In fact, Food Technology recently identified a dozen hotspots around the world that are building a reputation for specific types of food system innovation. Recently, Deputy Managing Editor Kelly Hensel spoke with Chris Downs, Director of the Food and Beverage Accelerator at the University of Queensland, on why Australia has become one of those global hotspots.
I wanted to get your opinion on kind of what do you see as the biggest factor or factors in a region becoming a hotspot for food innovation?
Well, for me, I guess a key feature is to have government working closely with research and academia and with industry. By working closely together, we call this, in this part of the world, the triple helix approach. And this is where government must really have the enabling policy settings and the investment support available for research and industry. And researchers really do need to have the capability to work with industry. This is not just about doing great research, but it's about doing research that leads rapidly to innovative outcomes and to value for industry. And finally, for industry, we need to be able to access and work with companies, whether they're startups or small to medium companies or even larger companies that have high innovation potential. They've got strategies and they've got investment to ensure valuable outcomes are being delivered. Now, in Australia in recent years, the access to venture investment has grown substantially for companies across the agri-food sector. So by bringing government, research and industry close together and providing investment, it's really what enables a great hotspot for innovation for food.
So for the hotspots that the author wrote about in our article, I think all three of those are obviously at play for the 6 hotspots. And I'll just name them really quick for our listeners, but Pittsburgh for agricultural robotics, the Netherlands for high-tech farming, Southern Africa for insect protein, India for regenerative agriculture, Singapore for alternative protein, and Australia for seaweed. And I'm sure you have thoughts on these, but I was also hoping to get your opinion on what other hotspots do you see forming?
Yeah, well, let me focus in on Australia. Great to see seaweed being profiled. This hotspot is mostly around climate concerns and methane reduction in ruminant animals. But there's also a whole lot more interesting stuff happening across Australia's agriculture and food and beverage manufacturing sectors. For example, in Australia in agriculture and robotics, an Australian company called Swarm Farm is leading the world for providing autonomous farm tractors to the world. Swarm Farm's a startup company that's based in regional Queensland here in Australia. And there's a lot going on around that in agricultural robotics as well. And across the food and beverage manufacturing sector, Australia's investing in startups in the circular economy area, taking waste and underutilized materials and turning them into value-added ingredients and foods that are now available to consumers both in Australia and around the world. And another example here in Australia is there's great investment going into companies that are working in the alternate, or we might call them the complementary protein part of the sector, bringing new foods and beverage products to Australian and international markets. Now, we know that growth in some of the plant protein products is moderating, but there's still significant growth potential and therefore another hotspot for innovation around complementary proteins.
That's really wonderful. I love hearing about the other advances and the other innovation happening in Australia. And I was wondering how your work at the Food and Beverage Accelerator is helping to kind of accelerate those innovations and other innovations throughout Australia.
So here at the Food and Beverage Accelerator, and we call ourselves FaBA for short, we work across Australia, and we're hosted here in Brisbane at the University of Queensland, and we bring together significant capabilities from 2 other universities. We like to say that FaBA is industry-led, and we make performance-based investments in innovation in projects with startups, with small and medium-sized companies, and in larger companies. Our total portfolio is $160 million, and we're investing in companies already that are stretched right across Australia. Some great projects and some great companies that are out there that we're working with. Our investments in FaBA aim to increase the speed of commercialization of university research with industry. We really want to see value come out of the investments that we make. An example of the sorts of investments we're making is in the area of precision fermentation. We're bringing together government investment with leading university teams, with startup companies who are developing new dairy proteins and other elite molecules that are going to be used as ingredients in food and beverage products. Now, these investments to date are with startup companies such as Algae Foods, Eden Brew, and Nourish, but we've got a number of other companies that we're working with in our pipeline soon to be announced. We're also wanting to stimulate and grow the overall precision fermentation sector here in Australia. And so we're investing in pilot plant and scale-up infrastructure that will enable companies to scale effectively and get products into market quickly. I guess to summarize, we like to say that industry success is FaBA's success. And so if our investments are leading to new food and beverage products or new ingredients or new skills in industry, then we're getting a great return on our investment. Indeed, we're aiming to deliver and are delivering value and benefits to Australia.
And I know the precision fermentation area is obviously a hotbed of activity lately. And I think it's so vital that you said that you guys are working on these facilities to scale up, because that's going to be so critical for precision fermentation startups and companies to be successful. So how is that going with the work that you are doing? Or have any of them opened yet, or in the future?
So we already have a pilot facility, got lab scale facilities, and that's what attracted a lot of the companies to work with us. We've got some pilot facilities that are here in the state of Queensland. We're investing to actually scale that even more. Announcements soon coming out about when that'll be open. And this is where government is coming in and working very closely with industry and with the researchers in the sector, so as to identify the ways in which their investment can really stimulate not only an individual company's growth, but actually overall sectors' growth, so that they can get to the market at scale as fast as possible.
So it sounds like the Food and Beverage Accelerator's already done a significant amount of work and made significant headway in various sectors, such as precision fermentation. I'm wondering, what lessons have you learned that might be able to be used across countries or disseminated to other countries to scale up their impact?
Look, we're already working a lot in Asia, in Singapore, for example. The Australian government, the state of Queensland's government, actually supports missions into Asian countries. We were recently on a panel in Singapore, working with our colleagues in Singapore, learning from our colleagues in Singapore. Many of our companies see ultimately that there are market opportunities for exports from Australia into Asia, into Singapore, Singaporean markets. The regulatory frameworks are very permissive in Singapore, so it's a great place for some Australian companies to go early and to scale early and to try products in market early as well.
That's wonderful to see that collaboration between the countries. Well, I really appreciate you taking the time, Chris, to talk to me, and I hope you have a great day.
Chris Downs is the director of the Food and Beverage Accelerator at the University of Queensland in Australia and a past president of IFT. Read more about Australia and other innovation hotspots in the March issue of Food Technology. We'll be back with more Omnivore in a moment, But first, this word from our sponsor.
Empower your business to reduce the negative impacts of recalls with IFT's new one-stop resource, the Enterprise Traceability Education Suite. Known for its impartiality, IFT's Global Food Traceability Center developed the comprehensive Enterprise Traceability Education Suite as the only education solution designed to quickly help get your entire organization up to speed on key traceability concepts. Get practical steps to designing an effective and cost-efficient traceability program. With IFT's Enterprise Traceability Suite, you save valuable time and money in preparing for FDA's Traceability Rule January 2026 compliance deadline. Find out more at ift.org/traceability.
Welcome back to Omnivore. I'm Bill McDowell. Researchers at Tufts University have developed bovine muscle cells that produce their own growth factors, which the team believes can significantly reduce the cost of producing cultivated meat. Growth factors bind to receptors on the cell surface and send a signal for cells to grow and mature into different types. Researchers for this study, which was published in Cell Reports Sustainability, modified stem cells to produce their own fibroblast growth factor, or FGF. Food Technologies Associate Editor Emily Little spoke with lead researcher Andrew Stout about his research on growth factors and where this methodology might take cultivated meat production.
Andrew, thank you so much for talking to me today about your new research.
Thank you very much for having me.
So I want to set the groundwork first before we get into what exactly your study showed. So can you explain what are growth factors when it comes to cultivated meat?
Yeah, totally. So basically, when we produce cultivated meat, what we're doing is we're trying to replicate the body's processes in an in vitro environment, so outside of the body. And one of those big processes is giving the cells everything that they need to survive and behave the way that we want them to behave. In the case of cultivated meat, that's often to grow and divide and produce a large biomass, and then also to differentiate into relevant tissues like muscle or fat. And the inputs that we give the cells, there's kind of two categories. There are the nutrients, so sugars and proteins that the cells need. And then the growth factors I like to think of as sort of the instruction manuals on how the cells should behave. So they're proteins that bind to cells and tell cells, hey, you should divide, or you should differentiate into muscle, or you should behave in X, Y, or Z way.
And I remember reading in the report that the growth factors is where the cost really comes into effect. Can you explain a bit more about what makes them so expensive?
Yeah, they're expensive, I'd say, for two reasons. The first is that traditionally they're produced for medicine and biopharmaceutical applications, which allows for things to be really, really expensive. They're produced at pretty low scale because not many are needed for biopharmaceutical applications. And so that kind of provides this sort of market reason why they're pretty expensive right now. And then the other reason is that they're produced recombinantly. So they're produced in other organisms. So typically it would be bacteria that are engineered to produce a lot of this growth factor, spit it out into the bacterial cell culture, and then it's kind of purified and isolated, and you're left with this protein. And that's just a whole nother bioprocess. It's a whole nother infrastructure that's required for the production of the growth factors. And then you use the growth factors. So it's kind of this, it's like this whole other pretty complex bioprocessing supply chain before we even, get them and use them for cultivated meat production.
So getting into your study, you were able to engineer bovine cells to create their own growth factors. Can you talk a bit about how you went about this and what the results were?
Yeah, definitely. So the premise was basically the way I like to kind of talk about it is there's the parable that says, if you give a man a fish, he'll eat for a day, but teach a man to fish and he'll eat for life. That's kind of what's happening with these growth factors. We're giving the cells instructions all the time on how they should behave, But really what we can do is we can sort of wire those instructions into the cell. So the way that these growth factors work is they bind to surface receptors on the cells, and it induces a big signaling cascade within the cells. And there are many ways to turn on that same signaling cascade without the need for adding a growth factor to the media. One of the ways is to have the cell produce its own. So basically the cell makes the protein growth factor, it spits it out, and then immediately it binds right onto that cell's own receptor and induces those signaling cascades. And then the other way is to basically just turn on the signaling cascade at some other point down the line, sort of internal to the cell. So the study was basically, we wanted to explore those two methods for removing the external growth factor from the picture.
And what did the results show? Was it successful?
It was successful, yes. As with all scientific studies, it was successful with a ton of caveats of how it still needs to be improved and all of that. But I'd say that the basic sort of proof of the principle was borne out, where the cells were able to grow in the complete absence of this exogenous growth factor. It resulted in really big cost savings for the cell culture. I think that we just did this for one growth factor called fibroblast growth factor, but these cells need many different types of growth factors. And I think that you could definitely engineer a cell where not only does it not need fibroblast growth factor, but it also doesn't need insulin, and it also doesn't need transforming growth factor, all these other things that sort of behave the same way in cell culture. And so I think I was pretty happy with our ability to prove the concept that I think, we could eventually move towards growth factor free cell culture in a cultivated meat standpoint, which I think would be really powerful for lowering the costs. At the same time, we saw that, so I'll try not to get too into the weeds on this, but basically this growth factor, fibroblast growth factor, it kind of does two things. It instructs the cells to grow, and it also instructs the cells not to differentiate into mature muscle, but to stay as a sort of dividing cell phenotype, a stem cell phenotype. And so by adding a bunch of extra fibroblast growth factor, we have a situation where we're able to improve the growth in the absence of that factor in the cell culture media. But then we saw a little bit reduced differentiation when we tried to differentiate the cells after. I think they're all really solvable problems, but I think it was an exciting proof of concept, but probably not quite ready for prime time.
I think that's so interesting. You talked about the cost savings. In my research of cultivated meat, that's always the number one thing that comes up, is it's so expensive, but it seems like you're meeting that problem head on. Yeah,
definitely. I mean, this was a project that I'd had my eye on for a pretty long time in grad school, and there were we kind of needed to put together all the pieces to be able to finally ask the question that we wanted to ask. But I was really happy that we were able to, say, hey, if we look at this breakdown of what the most expensive component in this culture media is, boom, it's right there. It's fibroblast growth factor. So let's try to address that one.
In your study, you used bovine cells for your research. Can this be applied to other meat cells?
Definitely. Yeah, definitely. I don't think that there is a species that we typically think of as a food species that doesn't include growth factors. And so I think that really similar processes could be applied to pig, chicken, etc.
So what's the next step in your research? Where do you go from here?
Yeah, so I think for this project and kind of this whole sort of premise, I think that exciting future directions include proving that, you really can do this with all of the other growth factors as well, sort of asking how far can you take that. I also think tinkering even more with sort of the internal mechanisms of the signaling cascades seems really exciting. So, the approach here is, well, growth factors needed, and so let's have the cells produce growth factor. But once that growth factor binds to the signaling receptor, when I say it's a signaling cascade, it's actually probably 10 different signaling cascades that happen. So if they're always like the most confusing images in the textbooks, but basically you see you go from one protein and then it kind of causes proteins ABC to interact, and that leads to the expression of gene A, or it causes proteins DEF to interact, and that leads to the expression of gene Y. And so it's this really complex network. And I think that it'd be really cool to explore how, tweaking different parts of that network at different depths down the chain affect things, I think is really exciting. And then I also think that aiming towards the same general goal through, rather than sort of genetic engineering gene insertion techniques, using some of the new sort of gene editing strategies that are out there. So, CRISPR-Cas9 is a really powerful tool for making tiny changes to the cell genome, which is both elegant and it's kind of has benefits from a food consumer perspective, from a regulatory approval perspective. So I think there's a lot of ways to sort of approach this problem in ways that make it more consumer friendly, more regulatory friendly, and where you get maybe even more sort of exact control over the system.
That sounds great. Well, Andrew, thank you so much for talking with me, and I can't wait to see where this goes next.
Thank you very much for having me. It was a pleasure.
Andrew Stout is the Director of Science at the Cellular Agriculture Commercialization Lab at Tufts University, as well as the co-founder and Chief Science Officer of Deco Labs. You can read more about his research in the March issue of Food Technology. Although the FDA's food traceability rule, known as FSMA 204, requires compliance only from companies making or handling items included on the list of high-risk foods, it does aim to spur end-to-end traceability throughout the entire food chain. Experts say this makes sense not only for protecting public health, it can also make good business sense. One of those experts, Dr. Jacob Bruun-Jensen of Monitor Deloitte, says that traceability roadmaps can reduce costs and increase efficiencies by reducing food waste and improving supply chain visibility. The key is to understand the data, process, and stakeholder challenges. Food Technology's Julie Larson-Brisher caught up with Bruun-Jensen to get the inside track on how food companies can tackle the challenge of traceability one step at a time.
Hi, Jacob. Thanks for taking the time to talk with us today.
Oh, it's my pleasure, Julie.
Well, we've been doing a lot of features on traceability and FSMA 204, and I know Deloitte has also been doing work on this area, so I'm really glad to have you on the podcast today. Let's start out with talking about some of the challenges. I know that in a recent article, you and your co-authors had identified 4 main challenges, but I just want to talk to you about 3 today. And let's start with the data challenges. What are the biggest data challenges that food companies are facing in designing a strong traceability program? And why do you think that is?
Yeah, great question. Data challenges sort of fall within sort of 3 broad buckets. So firstly, the key data elements as specified in Rule 204, depending on where you are within the value chain, you need to collect between 84 and 178 different data elements or data attributes, as we also call it, for the food items on the food traceability list, right? If you are simply trading products like a wholesaler, you don't do any transformation to the products, you're probably in the 84 data attribute range, versus if you actually receive products, you transform them, and then you ship them on, you're closer to the 178 data attributes. And those attributes, in some cases, you have today, and in some cases, you need to go out and collect and acquire these data. So the lot code information, in some cases, you will not have that today, and you need to go and get that from your suppliers and be ready to share that with your customers. In some cases, you don't have all the product data that is specified in the regulations, so you need to go out and get that. Same with location data. And in some cases, you also need to be able to track the transactional data by the different lot codes so you know what you received. So that's the first challenge, just the sheer amount of data you need to collect and be able to store for 24 months and then transmit on to your customers is a little bit daunting. On top of that, then you got the critical tracking events, or CTEs, as they're called in the regulation. That goes from everything from, receiving, transforming, shipping, first land-based receiver. That information you also need to be able to share with your trading partners, basically explaining what you've done to the products. So if you received them, great, we need to know that. Once you ship them, we need to know that. And if you've done any transformation. So there's a fair amount of new data, in some cases up to 50% extra data that you don't hold today in your systems that you need to go out and get. So that's the first big challenge, right? Do I have all the data that's required by the regulation? The second thing is then the data standardization and interoperability. So do I have the data in the right format? And can I transmit that data to either receive it from my suppliers or transmit it to my customers in the format that they require as well? So the ability to standardize the data and transmit it to suppliers or customers is also incredibly challenging in this whole regulation. So those are the two big ones. There's then, how do I structure the data? We call it data architecture. That needs to be thought through, and then the whole data governance. But the biggest challenge, in my opinion, is really around, do I have the data that's required by the regulation today?
Right. And that there's a little bit of overlap, I think, on the next challenge that you identified, which is process challenges that are associated with FSMA 204 implementation. That there was two main process challenges that was identified, and one was a lot level traceability and the other was labeling. So again, kind of about data management, right, and communicating it. How do you transmit it? Can you tell us a little more about those challenges and maybe give an example of a process change that will have to take place to overcome them?
Yeah, this is the second biggest challenge, which is how you have to change the way you work in order to be compliant. The first challenge is really around the lot level traceability, right? A lot of suppliers and producers today do not adhere to a global unique identifier per se, right? So we need to create a lot level tracing number. And how do I standardize that number and transmit it is, part of the data challenge. But now I get these products. The challenge for me, if I'm a wholesaler or if I'm a retailer, is I need to be able to tell which ones of the products I just received the pallet off are actually on the food traceability list, and therefore I need to scan and record, and which ones are not. So this is a big discussion amongst companies today. Do I have a flag that then identifies for the people at the receiving dock, this product you need to scan and to capture that? Do I capture all the information within a certain category? And I just, I get everything that is fresh produce. I just scan everything because that will make life easier on the dock. Or do I do it with some other identifiers or attributes and says, this is the way you now need to scan these products, right? So that's a real headache to figure that out, and will require process changes because effectively we're now asking the person on the dock, receiving dock, to scan and do work differently. So that's the first challenge. The second one is I get a pallet of products. Typically, they will show up with we call it a license plate, right? That will sort of saying, hey, on this pallet, there are these boxes on it. And I could get an advanced shipping notice that tells me exactly what's on it. Typically for some suppliers, they're able to do that, but a lot of suppliers are not able to provide an ASN. So that's, in itself a challenge for, again, the people on the receiving dock who are now going to look through this and be able to now have to potentially break up a pallet and instead of just scanning the license plate, they now have to break up the pallet and scan different products. Same goes for put away. If you're putting it into the warehouse in a slot, you need to be able to track where that lot code went with, where you put it. And then when you're ready to ship it, again, they need to scan the lot code and put it on the pallet and saying, this is now what's on this pallet I'm going to ship to the customers. So all these require process changes that need to be thought through in order to be compliant.
Right. And that kind of, when you're talking about the guy on the deck and having to work differently, it probably also includes now we've got to train people differently, right? And I think that kind of segues into the third challenge that you identified, which is stakeholder readiness. It's internal and external, is from my understanding. Can you outline those kind of challenges? And do you have any suggestions for best practices in instituting like a company-wide traceability culture or training programs?
Yeah. So there's sort of three different stakeholder groups you need to be thinking about. And you quite rightly pointed it out, Jude. The first one is really the internal one, right? The people who are going to get impacted by this change. So first thing you need to do is, of course, make them aware of it, right? This is going to come. We need to be compliant by January 2026. So you need to be aware of it. The next thing you then have to do is to tell them how their job is going to change because of this. So they're aware, they now understand what the changes are likely to be. Then you have to train them on this is how we're now going to change and work differently. And then, of course, you need to be able to reinforce it once you train them so you make sure they do it in the right way. So that's what you need to do internally. And you should not underestimate the effort in change management to get and be compliant. It does not just touch on the food safety and quality assurance team. This cuts across multiple functions that now need to be trained and be compliant. So that's the sort of the internal stakeholders. External stakeholders, depending on where you sit in the value chain, but you have suppliers that you need to make sure are compliant and can share the lot code traceability information with you in the right format so you can read it in order for you to be compliant. So you need to have a program in place to deal with your suppliers. And then on the other end of the value chain, you need to be able to work with your customers, make sure you can share the information with your customers in the right format and they can receive it and use it for their traceability as well. So you've got these sort of three different stakeholder groups that you really need to think carefully about how you manage. And again, depending on where you're sitting in the value chain, that challenge can be daunting in some cases, right? You can have thousands of suppliers you now need to reach out to and make sure they're complying with the regulation as well. So that's sort of how we're thinking about the change management.
So are you optimistic that a lot of these challenges can be overcome by January 2026, or is it going to take a little longer?
We are cautiously optimistic that the industry will be compliant by January 2026. And what I mean by that, Julie, is we think there will be some who will definitely be ready and be compliant. And I think there will be some who will sprint to the end in order to be compliant. But I think the industry has got the capabilities and have got the right resources to be compliant. And now it's just a question of we make it a priority. We got less than 2 years now to be compliant, but that should be sufficient time to do this in. But unless you get started on it now, you're probably going to find you're going to sprint and you're going to run really hard towards the end. I want to finish on a positive note, Julie, because this is not all a bad thing for the industry, right? This is not just an additional cost doing business. It actually gives every participant in the supply chain and the value chain the opportunity to create greater visibility. I can suddenly track my products through the whole value chain and get additional insights that allow me to manage potentially food wastage I can potentially cut down on that, allow me to be smarter about how I manage my inventory, where I ship products to. So I think there's a ton of great things and upsides in this, but of course, there's going to be a short-term pain from doing it.
Right. Well, thanks so much for sharing your insights today with us, Jacob. And I look forward to talking to you later in the year. We'll be covering the fourth challenge, which is the technology challenge that's associated with FSMA 204. And maybe next time we'll talk a little bit more about your winemaking passion. And I'll bring the Oregon Pinot.
That'd be wonderful, Judy. I'm looking forward to it.
Jacob Bruun-Jensen, a principal with Monitor Deloitte, is a senior corporate strategist and the co-author of Deloitte's article, FSMA Section 204, Traceability and Tracking in the Food Industry. Get more advice from Bruun-Jensen and other industry experts on how to up your traceability game in the March issue of Food Technology.
Thank you to this episode's sponsor, IFT's Global Food Traceability Center. Get ahead of FDA's Food Traceability Rule January 2026 compliance deadline with the Enterprise Traceability Education Suite, your one-stop resource for comprehensive traceability training. Empower your workforce with this efficient and cost-effective training tool at www.ift.org/traceability.
And that wraps up this episode of Omnivore. Thanks again to all our guests and my colleagues at Food Technology. Omnivore is produced and distributed by the Institute of Food Technologists. If you enjoyed today's show and want to learn more about Food Technology Magazine or how to join the conversation by becoming an IFT member, visit ift.org/membership. For more in-depth discussion about innovation in the science of food, check out IFT's other podcast, Side Dish, on the News and Publications page of ift.org. If you have comments or suggestions for future shows, just send us an email. The address is editors@ift.org. For the entire team at Food Technology and IFT, I'm Bill McDowell. Thanks for listening, and join us again for our next episode. This is Omnivore.